Okay, so apologies for the focus here. It didn't print out properly, but that's okay. So letter E says that on a map of Great Brook hiking trails, 1 centimeter corresponds to 4 miles. All right. It says find the length of the trail by the line that is 2.5 centimeters long on the map. So what they're trying to do here is trying to figure out what the mile is based on the ratio that they gave you, or basically the scaling. Sometimes ratios will also be known as scaling. All right. So in this particular case, it's telling you that 1 centimeter on the map will correspond to 4 miles. And they want to find out how many miles is represented if you have 2.5 centimeters. So when you're doing these applications, unlike our previous ones, it's always a good idea to go ahead and map out your ratio first. So in this particular case, what we're going to do is we're going to go ahead and compare the two units that we're comparing to. We're comparing centimeters to miles. So it's always a good idea to address what ratio you're dealing with, so you could set up your ratio, your initial ratio, and then eventually your proportion. So in this case, they're letting us know that 1 centimeter will be equivalent to 4 miles. So once again, we're comparing centimeters to miles. So 1 centimeter will be equivalent to 4 miles. So to set up the proportion here, we need to set up the second half. Now one would be known and one of those parts will be unknown. Now it could be either the numerator or the denominator or vice versa. It just depends on the way you do the initial setup. In this case, they're letting us know that they want to know how many miles will be represented on the map if you have 2.5 centimeters. So once again, 2.5 centimeters. Will it go in the numerator or will it go in the denominator? Well, the way we set this up, we set it up as centimeters to miles, so it has to go where it was set up initially. So in other words, the 2.5 centimeters has to go for the numerator there. So you don't have to put the mixed fraction itself. You could just simply put 2.5. And the unknown part will be your x. In other words, how many miles it represents. So, like before, we're going to multiply diagonally, just like the technical aspects that we're dealing with before. So remember, the first thing is to set up your proportion. Second thing is to go ahead and solve for it. So we multiply 1 times x, which will be 1x, or simply x, and 4 times 2.5, which will be 10. You don't have to divide by 1 because it's already understood that we already have that 1 in front of x right there. But if you had any other number in front of x, then the next step would have been eventually to divide. So for this example, 2.5 centimeters represents 10 miles. All right. Now there's not going to be too many applications that we'll do because there's not that many problems there. But it's always a good idea to take a look at these to get some more practice on them. Next problem is in part 2. There's 2 of them, A and B. These are very similar to what you're going to see in your lab assignment. One is dealing with the triangles and the other one is dealing with the shadow. So what we're dealing with in letter A is you have a smaller triangle and you're going to compare it to a larger triangle. So it says find the missing lengths in the similar triangles. So when they mean similar, it doesn't mean exact. It means that they're some way, somehow proportionally equivalent. So the same thing as before. Well, this 14 corresponds to this 18. This 28 corresponds to this x right here. So we could set up a ratio here of 14 over 28. So let's go ahead and put that. So this is number 2a. So the ratio here is 14 over 28. Remember, we're dealing with a triangle here. So the 14 corresponds to that 18 right there. So we know where the 18 is going to go. And the missing side here is your x. So that's the one where we need to calculate this. Alright, so I'll go ahead and give you a minute here to go ahead and calculate this. And I'll be back in a second. Okay, class, so once again, the same thing that we did before. We're going to go ahead and multiply 14 times x. So that's 14x. And we're going to multiply 28 times 18. So once again, make sure that you clear your memory from your fractions, from your calculators. Sometimes it remembers what you previously did. So you should have gotten 504 for that. And once again, recheck that just to make sure. So 28 times 18 does give you 504. And just like before, we're going to go ahead and divide both sides by 14. So we go ahead and divide 504 divided by 14, and that'll give you 36. So on the larger triangle, the bottom part right there is going to be 36. So once again, hey, we take a look at this. The bottom part here will be 36. Alright, let's do one last one, letter B, and this will conclude section 6.6. It's not that hard. Don't worry about problems 3 or 4. You won't have something like that. But let's take a look at letter B. So letter B says Ben is a rock climbing in New Mexico. He is 6 feet tall and his shadow is 4 feet long. The rock he wants to climb casts a shadow of 250 feet. How tall is the rock? So essentially what we're dealing with here is his height against his shadow. So once again, it's always a good idea, especially if it's not a figure 1 like we had before, to always go ahead and label your ratio. In this case, it'll be the height of the person against the shadow. In other words, height over the shadow. So that's how you're going to set up your initial ratio. And eventually, that's the way you're going to set up your proportion as well. So they're telling us that this climber is 6 feet tall. Alright, so he's 6 feet tall, but yet his shadow only casts a shadow of 4 feet long. So that is your ratio. Your ratio is 6 to 4. What they want to try to figure out is how big the rock is. It says the rock he wants to climb casts a shadow of 250 feet. Alright, so the shadow, mentioning right here that it is the shadow of the rock. Once again, the rock he wants to climb casts a shadow of 250 feet. They want to know how tall is the rock. So just like we did right here, the shadow will go where? For the denominator part, and you're trying to figure out the numerator part. So this will be 250, and once again by default you're going to put an X on top. Once again, you don't have to label it as X. You can put really whatever variable you want. So what we're going to do is we're going to multiply diagonally just like we did before. So 4 times X will give you 4X. And we're going to multiply 6 times 250. So if we go ahead and do that, multiply 6 times 250, that'll give us 1500. So 4x is equal to 1500. And finally, we divide by 4. So we're going to go ahead and divide both sides by 4. So x, and let me pan it down a little bit more. So we divide it by 4 will give us 375. So it's 375 feet. So that's how tall the rock is. Once again, this is not a difficult section. You just really have to concentrate on what aspects are you dealing with. Are you dealing with an illustration like the one we had before, or are you dealing with a verbal? Alright, so this goes ahead and concludes section 6.6.